Hi guys, welcome to Learn Electronics Repair. I have something to review today. So this is from Fnirsi. They sent me this free of charge, so this is a free review sample. However, I'm not being paid to make this review, and I'm going to express my own honest opinion of this product. This is the LCR-ST1 Intelligent Bridge Tweezers. I've not reviewed anything quite like this before. It says rapid precise measure, data hold, magnetic suction, various lightweight, USB-C, a little bit of information on the back. But I think what we'll do first is have a quick look at the Fnirsi website. Let's see what features this has, and then we'll try it out and see how well it works for us. And here it is. Mini Smart Tweezer LCR, so that's Inductance, Capacitance, Resistance, SMD, ESR tester. Okay. We can see portable multifunctional instrument for measuring resistance, capacitance, inductors and diodes. I'm pretty sure straight away this is intended for in-circuit use. And we can see the price, a fraction under $40. If there's any discount codes available, by the way, I will put them in the video description to this review, so have a look in there if you're interested. It's got a lot of ratings which seem to be very high. We'll have a quick look in a moment, but let's see what this does. This appears to be an in-circuit tester. LCR means inductance, capacitance and resistance, of course. It also says it measures diodes. It measures ESR, okay. So this is an in-circuit tester down to 10 milliohms, okay, interesting. We can see the capacitance range. Oh, and two types of heads, so pointed heads and hook heads, okay, to attach easily to different types of components. So this is not a multimeter. This is not to measure voltages. This is for working on boards which are not powered up, okay, especially SMD component boards. We have different test frequencies, shows the test voltage which is low, so it shouldn't damage anything. I will just mention, by the way, that a standard ESR meter operates at 100 kilohertz, okay. Whether that is of any relevance, I don't know, but it was worth mentioning, I think. Yes, and we see capacitance, resistance, inductance, diodes, continuity, or finding shorts, I guess. And we can adjust the, I'm assuming, voltage level, it must say, level and frequency, okay? Automatic recognition of the type of components you are testing. And we see actually use here out of circuit and in circuit, okay. And here are the values it gives us. Dissipation factor, I'd have to look that one up. Total impedance, quality factor, this is for tuned circuits basically. Reactance, that's capacitance, inductance, and ESR. Okay, so we know what this does. Let's try it. And here we have the protective case. And the tweezers. We have a charging cable, which is also a data transfer cable. The obligatory Fnirsi badge that you always seem to get. QC pass. We have some additional tips here. So these are curved ones. Okay. Little metal plate. User manual and the tweezers. Let's have a look straight away at these. So we'll take off the little screen protector. Quick touch. Power. It bleeped. And it's asking me for the language. There's just the one control here, so this rocks backwards and forwards and also presses. Yep, went to English, press. Okay. So it's now telling me that the tweezers are open. This display is really bright, by the way. Really bright. The battery isn't fully charged. Fair enough. This has been in transit. And it's saying auto. This is the mode. Now we can change the mode. Resistance. Capacitance. Inductance. Diode. And back to auto. We push the button. We're now on the voltage setting. 0.3, 0.6. I'll leave it set to 0.6. Again, this is the test frequency. Now, I didn't see any particular information as to which one you should use when and where. So I'm going to leave it on 1K. That's the standard setting. Press again and we're back to the auto, resistance, capacitance and so on. This is the hold button, so we press this and it will hold the reading. I guess that's useful if you can't quite see the screen while you're actually measuring something. You can hit hold and it will keep the reading on the screen for you. And long press on here will switch it back off. Let's see if it comes back onto the previous settings. I'm on resistance there. Switch off. It goes back to auto, okay? We can press the button, we're on 0.6 volt. Let's just change it. 0.3 volt. Switch off. Switch on. No, it doesn't remember your settings. It always goes back to that, okay? The default. If we press this long, hold it in, that takes us to the menu. So we can see English, Chinese, and we have various options, language, volume. We press on that one, yeah, then we can, let's turn it up so you guys can hear it better. Backlight and auto switch off, which is off at the moment, okay? Right. Long press again comes out of here. Yes. Okay, so the interface is very easy to use. I'll give it that. This has a 250 milliamp rechargeable battery, USB-C. According to the Fnirsi website, this will give about 10 hours of normal use, whatever they class as normal use. And it takes about 2 hours to charge from a fully discharged battery. Here we have the specs, so it should read very low value capacitors, upwards to 22 millifarads. Okay, that's rather a lot. Inductance from 10 microhenries up to 10 henries. Okay. Resistance from 10 milliohms up to 10 megaohms, so there's different ranges. It also gives some accuracy readings at different frequencies. We can see that. It looks like we have to use the 10 kilohertz to get the very lowest ranges. That makes sense, to be quite honest, because inductors and capacitors will effectively give a better reading at a higher frequency, if you like. And we see an explanation of the screen here. Tweezers are easy to change, little thumb screws. No tools required. And then some operating instructions. I'll just highlight this information. So this has short circuit zeroing. It's telling us to select the test frequency that we want to zero, insert a short circuit piece into the test socket. I think that means just squeeze the tweezers together. Okay, short press the power button to enter zeroing mode. The instrument will automatically measure and it will zero. And we have the option for a firmware upgrade. It also mentions that the automatic does not support diode measurement and automatically detected component type is for reference only and may lead to misjudgment under special circumstances. Okay. And the same, not recommended for online measurements. Does that mean in circuit measurements? Okay, well, we'll see. Because we can compare this with a multimeter. And that's it. Oh, this thing, by the way, magnetic. So you can stick the sticky pad to something and you can just put your tweezers on. So that's what that's for as well. I'm sure that most of you want to see how useful this is as an in-circuit tester. So that's the way I'm going to review this. I have some scrap graphics cards here. We can see them. So let's try using this in circuit. We'll have a play with the auto function and then with the manual selection of the components. I'll compare the readings with my multimeter, capacitance meter, ESR meter, depending on what is appropriate. Obviously, measuring in circuit is not going to give us a totally accurate result in a lot of cases, but I'm interested to see how this compares to the other tools I have. So let's try this in auto mode and we'll see what we get. These are capacitors, probably in parallel, a lot of them. Let's just go on here, what happens. And that's saying, well, you can see it's 700 microfarads or thereabouts. And just trying different ones, they all read the same, so we can say these are in parallel. Okay, let me try that on my multimeter. There we go. What's this tell us? Well, it's a lot slower, but I expected that. $1,591, about double. Okay. Completely different again, about half. Okay. So we can say it's a useful comparative tool. Now then, this is showing the resistance at 15.916 milliohms. That is like the ESR. What does my ESR meter tell me? About 23 milliohms. I'm going to try this on a different frequency. I'm going to put it up to 10k. I'm interested to see how that affects the reading. Okay, 10k. It's very easy to use, by the way. Let's go again. It's now reading about 1.5 millifarads, okay? That's about 1,500 microfarads, which is basically what this meter gave me. Okay. So the reading is very much dependent on the frequency setting. Let's also try that in resistance range. Okay. Eight milliohms. My multimeter, I don't think will even read that low. It just says 0. And my milliohm meter. Let's see. Oh yeah, about 7.3 milliohms. Okay, so that was very accurate on the low resistance for sure. Very similar to this. Yeah, extremely close. That's interesting, actually. That surprised me a little bit. Let's have a look at some inductors. So these are actually marked R22, which I think is 22 millihenries. It'll fit around that. Yeah, and that's reading about 0.2 or 0.3 microhenries. I think that's what they actually are, or 22. Let's have a look. Yeah, that seems about right. And I have some more which are marked R47, so you'd expect these to read higher. Let's have a look at one. 0.4, yeah, so it reads that it's struggling a little bit at the very small ones. I mean, these are very low value inductors, 0.1 maybe. Okay, here's another one. 0.6. So it seems quite capable of reading very low value inductors. At least giving you some indication. Now, how about capacitor ESR? So we'll go to, that's diode, auto, resistance, capacitance, okay? Let's have a look. So we have a whole load of them here. These are quite often going to be in parallel as well, but let's just try it. So that's saying 1000 microfarad just about, and the ESR is 13 milliohms, okay? That's about 0.013012. Let's try that with my capacitance meter. Yeah, it reads about the same. How about ESR? So 0.013 ESR meter. Just get to the same capacitor. I'll just see if it's zeroed. Yeah, pretty much. 0.014. Yeah, it's similar. Okay. Let's try some of these small capacitors. Down by the PCIe connector, okay. What do we have? We have one there. We'll have to zoom out to see what it reads. Reads about 200 nanofarads when I get a good connection on it. That's about right for one of these, you know. They're normally 100 or 200. Yeah. I'll try with the other tips as well. Let's try the curved ones. This allows me to hold the meter much flatter. I've noticed, by the way, that these are actually, you know, I think I've put them on the wrong way round. That's why they look bent. Let's put them the opposite way round. Okay. Yeah, so these are definitely designed to go one way or the other, okay? Let's try. Yeah, I actually think I find the straight ones easier to use. These seem a little bit uneven in the length, but they're not uneven in the length. It's just you can kind of like push it in one direction or the other, if you see what I mean. That probably takes a little bit of getting used to. The straight tips didn't seem to have that problem. You see there, look, I've got like one flat on the PCB and not the other. Okay. Yeah, I don't like these curved tips. I don't think they're anywhere near as positive as the straight ones. Yes, they work, but with a lot of messing about, okay. Can't get a good contact, well then I do, okay. Back to the straight ones again. Yeah, they're much easier to use. And can we find any diodes on here? Well, this is possibly a bipolar transistor, so we'll go one way round on here. Doesn't show anything there. Could be a MOSFET. Let's just try here, try find the parasitic diode if we can. Yeah, there, got it, okay. So that's a parasitic diode. That was quite quick, to be honest. Well, it reads in both directions. Let's have a look. So this shouldn't read a diode, you'd expect it not to. Oh, that's interesting. So it shows you the diode junction regardless. Okay, let's try that on my multimeter. So that says no diode junction in that direction. Diode junction in that direction. Okay. Once again with this. Diode junction. So that second one up. Okay. This one. Diode junction. So this shows me I have a diode junction regardless of the polarity, if you like, that I'm holding this in. I'm on 1 kilohertz at the moment again, by the way, because I switched it off at one point. So that's back on the default levels. That's interesting. I'm thinking it probably won't see a diode if I go to 0.3. Let me have a look. Yeah, it won't see a diode junction now because I'm on 0.3. That makes sense. But on the 0.6, okay. It's, yeah, let's talk about it. So that was quite an interesting experience. What do I really like about it? It measures small value inductors and low value resistors in particular very, very well. ESR and circuit, although you cannot necessarily get an accurate reading, matched what my ESR meter told me, so that was also good. Yeah, the diode mode thing is, well, it's quirky. It's obviously because this is using AC. It doesn't tell you the polarity of the diode, it just tells you if you have a diode junction between the two tweezers. Whether that is what you wanted it to do or not, let me know down there. I'm kind of like, well, aye. But there again, there's no positive or negative connection either. So you wouldn't know which end was the cathode, even if it only is in one direction. Unless, like, you know, you'd played around with it a bit with a few diodes out of circuit. I would say it's a very useful tool if you're making comparisons between two PCBs. But there again, measuring components in circuit is never very much of an exact science, you know. It certainly does a job of a lot of things that I would have to get out separately. Will I use it? Yeah, I'm going to use this on some of my videos. We have the live stream coming up in just over a week. If you're interested, let's play around with this on the live stream. It's a nice little thing, you know. I think it takes a little bit of getting used to, but if one of these turned up in my birthday or Christmas box, I would be quite happy with that. And I'm sure you could have just a lot of fun with that. Get used to it. I think you can probably do some useful work with it as well. But as I mentioned originally, it's probably the most useful as a comparison tool other than like the low value resistors and stuff, which obviously worked very, very well on. Okay, let me know guys. Get down there. I won't give it an out of 10, but I'm sure you will. Let's play with it some more on some repairs and find out how useful this is as an actual repair tool. Okay, I hope you enjoyed that. Thank you very much to Fnirsi for sending me this free to review, and thank you guys for watching.